Welcome everyone. My name is Arivoli Tirouvingadame. I am a Senior Specialist Solutions Architect from AWS. I'm from the San Francisco Bay Area, and then I support the next generation development experience, Kiro and all the autonomous agents as well. And March 21 and 31, which is very recently, we launched DevOps agent and the security agent. So these are kind of fresh from the oven. And I have some demo towards the end, and I wanted to show my environment and all of these stuff. Okay. The topic here is reducing pen testing from weeks to hours. But the security agent not only covers pen testing, every SDLC stages like the design review, your code review, pull request PR plus pen testing. All these are covered at various stages. So we will take a look at it. Okay. We go to the next slide. First, we'll start with some marketing, some data points. Basically, especially with GenAI as well, the development velocity speed, it's actually it outpacing all the security testing or even development of security software to catch up. So we are always behind at breakneck speed, and we have tons of tools from various, let's say Cursor, Copilot, we have Kiro, and a whole bunch of other stuff too, and the existing tools as well. Okay, so 60% of the organizations, they update their web applications, weekly basis, and we need to actually catch up, also boost up the security to catch up with that, but it's kind of difficult, and also 70% of the applications actually the applications they are actually monthly they tested. Okay, so there's always a backlog you're running against time, and also let's say the most comprehensive is a pen test, manual pen test, but it takes 3 to 6 weeks, and also it is expensive, and we can only go with per application basis, not all your applications in your portfolio, and you will pick and choose which ones you think you want to protect more, like your landscape surface area, and which ones is worthwhile to kind of risky for you, etc. So these are kind of approximate ballpark numbers, 5K to 50K, per application, per pen test, all of those stuff. It's not like everything anyone can boldly say we are very secure, right? So that's where we start, and then so 81% of the times organizations actually knowingly release code, even though they didn't have it, because the business needs and competition, market needs, etc., is actually kind of pressing it. So this is where we are at. So these are all how we are, where we are, in all our data points which are actually running against us. Okay. Now what we can do is GenAI, all the new next generation development experience, etc. If we take these concepts into the security side of things, and we can see how we can holistically, just like manual pen testing, which is actually looking at everything in deployment, trying to actually have hackers and get down to the kind of findings, right? How can we actually go through the SDLC life cycle from every step of the whichever way possible, how we can improvise that. So that's where we are at. But before we go there, we will look at the traditional application security toolbox, what we were doing so far, and just to understand, to set a baseline. Okay, the first one is the static application security testing, which we all know. So one is these are the things that we've been doing so far. So you have people write code, developers, and then they actually check it into your Git or somewhere. So static analysis, nothing is deployed in production, and you don't know what. So by looking at this, you can run some tests, and then through code review process or something, you can actually give feedback, and people can actually, based on experienced people, right? So, but this is actually, you can do regex, pattern matching, or some kind of design patterns, standard stuff that you would have seen. So all those will come into play, and we were playing this portion, right? Second one is the dynamic application security testing. Here actually, it is actually in production, you've deployed it, and then you'll try to actually, hack it, test it, whatever. So, but in this case, what happened, the first one is too early. The second one is actually kind of too late. I mean, too late, or it's already happened, and now you're catching up, you're backpedaling, you're going back, hey, stop, patch, all of those stuff will be going on, and if you get into a bad press, it's even more not, confident boosting, right? So that is the dynamic, but we needed to see it in deployment, in production, in live, so that, we'll get that reality check, right? And then the next one is the software composition analysis, meaning over time, I mean, we all know this, like we use tons of open source softwares, also third-party softwares, which we kind of either buy it or contract it or whatever. So we are not the authors, and even though we have secured our code, but because of some dependencies, we won't be. It's not always difficult. It's always difficult to say, to confidently say that we are secure or whatever, right? And again, some of the issues may not even show up for many people, but in your application, those dependencies that you have on third-party softwares may bring up some new stuff. So there's always this, the risk is there. So that is the composition analysis, yeah. And then the last one is the manual pen testing. This is actually, you've deployed it and you actually have in a hacking mentality, bug bounty and all the stuff, you'll actually go try to actually kill the software or whatever, try to get around it, right? But this one it's very expensive, but this is the most, comprehensive maybe. So you'll pick and choose which application, because it's expensive and time consuming, 3 to 6 weeks, and you'll have to wait, backpedal, and if there's something that you find, then you have to go back, the whole 9 yards, right? So because of this, people generally, we all used to pick and choose which applications are most, very important for us to secure, and per application, all those things kind of so these are all the traditional approaches that we have been doing so far. It's a combination of some things depending on your company, situations and competitions, etc. So these are all the 4 things. Now let's talk about with the advent of all the agentic AI, and you also have the with the latest, how we can actually have autonomous agents, which can basically, let me go back one slide, take advantage of all of our experiences from the past life, like 3-4 decades of software development, SDLC, right? How we can actually get the best habits, recommendations from each, and try to come up with a solution. So this is fresh from the oven. So we would like you to actually give it a spin. And I have a demo, I'll show you then. Demo meaning there's like a report, and I'll show my environment. Security agent. This actually is a frontier agent. And another corollary to the sidebar, like you'll have a DevOps agent as well. So people use, basically what happens is whichever team that is, and we are offering these 2 agents, and you can actually, because it's all security agent today, so we'll keep with this one only. But basically for me, both are, they're all, I parallel look at both. Proactively secures your application throughout the development lifecycle. So this, we haven't been fully able to, reap the benefits from the past, but now we are able to, the approaches, we will actually look at combination of all of this from the past, the previous slide that I showed from the, traditional approach, and how can we actually address that, okay? So it's a context-aware, autonomous, pen testing that you can do. So what you can do is from the left to right, it's AI-powered pen testing. So it's a combination of the static, dynamic, SCA, and manual pen testing. That's the first block. Second one is the context aware. So all your documents, it could be in Git or Confluence or your SharePoint or whatever. All of it. So the one is your the requirements documents maybe, and your design documents, your architecture documents. All of those, and then at some point, before the developers start, as part of your documentation architecture, database designs, APIs, and then which ones you want to expose to the UI, all of the blast radius that you have, all those kinds of, and then the DevOps scripts, right? Whether it's cloud, the infrastructure as code or CDK, whichever way that you have, Terraforms maybe, all of these. Either they're checked into your code base, or it is sitting in some kind of shared point or some kind of a folder, right? All of these we can take a look at, the agents, or with our Gen A agents, everybody, right? Then you can have a context awareness of what this application is trying to do and what are all the areas the code shows it is actually doing. So then we can actually come up with an attack plan, attack plan for your application. We, reading at our code, what we have done, we can come up with an attack plan how to try to see, like how you can actually kind of penetrate the system or something. So that is possible because we have the complete context awareness. Previously, we didn't have that full view. So we'll be going with best practices, regex, and pen testing, and etc. Then finally, the verified security risks. So when you have some vulnerabilities, you can chain them up, okay, and then with good validated kind of knowledge base that you have, or from the past that you have been doing, and you can actually the idea here, long story short, is like reducing the false positives and the alert fatigues. Usually what happens, how many of us, practically, like whenever you get this report or even code review, simple, not even security, all of these, do we have fun? We just wanted to get through this, push the code in, get this thing passed, and whatever minimum stuff that you want to do, you want to get it, generally, right? But here what we're trying to say is, we are trying to actually make it more, enjoyable as well. So you will actually reduce the false positives and alert fatigue, so that whatever that you get is actually kind of meaningful. So it's not like you're looking at many things and you're actually kind of culling out a lot of stuff. All of these is possible because we have kind of rich set of context, and also you will have your current run books, etc. Your DevOps people will be giving some things, and how when something happens, what do you do, or your security CISO or security experts and all, right? All of those you can, and then you can actually change the vulnerabilities, and you can actually have a reproducible set of the plans. Now let's go to the proactive. So we have looked at all the past, and the security agent, we've looked at what all it can do, the three kind of main functionalities or pillars. Now we'll see how we can actually proactively secure during the life cycle of software development life cycle in SDLC, every step of the way. So one is the first stage, and let's take the the code tools that we have today. So we have in a cloud, we have Makiro from AWS, and we have like Cursor, Windsurf, etc. So pretty much open open spec and all. Pretty much there is a design phase, requirements gathering, design, etc. that happens first, and then the second one, once you graduate from there, will be the tasks and actually going, skills, etc. And then you'll start actually, and then you'll develop the code. Yeah. So what we're going to say is, when you have the requirements gathered, okay, and then when you're doing the design phase, design review, these are all like, not code has been produced, but just like by reading lots of documents, because your architects, your business people, requirements gatherers, all of those, the concerted effort will give the fruit of a design. You can review that. You can actually nitpick right there itself. So that's one. This is actually, I'm going to walk through every stage of your SDLC. You can evaluate documents against you. So you will have, for your company, you will have a baseline today, whatever baseline requirements that you'll have. So now with the new project design document, you can compare against that, and you can actually come up with design reviews. That's the first piece. Second phase in your SDLC is like, you will actually start churning code. When you churn code, let's say I will take an example of Git. So every developer towards the end, DevOps, security, whoever that is, you will raise a PR and you will push it, commit it into your GitHub. There you will be, typically you will be giving your own summary, or I'm trying to fix this, blah, 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 ticket number, all those stuff, right? In that stage itself, as part of one of the tasks, we can have the security agent actually go through this change set, which you have committed, which you're raising a PR, to go through against all your security baselines, blah, blah, blah. And finally, it can actually give you, flag you, or comments, or whatever that is. And one of the simplest things that you might have seen, it's not a, I'll show you some screenshots later. In your Git or somewhere, public or private, you would see all the automatons right now from various vendors. it'll tell you like, I suspect this one is this. Give me a thumbs up or thumbs down based on your review, right? So then sometimes I go and say, not for security, for some other purposes, is it like a duplicate of this? Is it like a whatever from the code, from the base that it saw? Then I say, no, this is not a duplicate. I looked at it, blah, blah, blah. This is unique. And then when I do a thumbs up or a thumbs down, then it actually coaches the agent, our automaton, and then it'll actually go fix it. Fix it meaning change the flag or something, keep it ready, push it forward or something. So that is, in the code review portions, you can actually look for security issues, and you can actually it'll give you some suggestions, comments, you can review it, and you can maybe fix the code, or like, you can actually say this is okay. Then the next one is the, penetration testing. This, discovers, chains, we talked about this, but today we do this, right? So multi-step attack scenarios we can have. So all of these is the various stages of SDLC. And finally we have this, works, wherever your applications are. So if we have this in AWS, and all regions, all any endpoint, public or private. We also support, you can also do this like, multi-cloud, whichever cloud, wherever that you're at, and hybrids, and any accessible endpoints as well. And then the next one is more context drives better. So the whole point is giving more context. So previously we used to have various subsets of developers who will be looking at security for their own areas. Now the more context that you throw in, you will be able to actually improve, kind of reducing the false alerts and the alert fatigue, etc. So we have the three boxes here, inputs, outputs, and then the agent processing. So inputs from the various stages of SDLC, you'll have this. These are all the documents which are available for us. So baseline requirements for your company, okay, which you have been doing today, and then you have your as the design doc is reviewed and written, and then you'll have the implementation, PRD, MRD, all those kind of stuff, right? All those you can look at it. You can see what is your database design or model, which fields are there, and the APIs, how secure are there, which ones you're exposing and not. All of those you can see, and then the infrastructure as code, ports, everything, the security groups, etc. You can see, and then ultimately you have the source code where you can actually look at from a very neutral, without even looking at any developers. This code exposes what, like that. You can fully read through all the engines, and then you have the runtime analysis from the past, existing threat models that you're always worried about, and you have some knowledge in the past, knowledge base, and your business logic, user stories, also the users, right? Our use case stories, test cases, etc. So what we are trying to provide to the company, to our customers, plus what all we have been. With all of these inputs, what the agent, if you supply this to the agent, ultimately what we're trying to do is an attack plan. With this, it can actually look at, because it has the code, it can try to fake you and try to see if it's able to, kind of penetrate it further. And if it gives us findings, then we can actually go fix our code or do something and kind of cleanse it up, right? So that's the attack plan. And then also, in your design docs, all your documentations, you will have the payload for your APIs, happy path, and even the bad test you'll have, but not like we cannot cover, generally we don't have time to cover all the security breach type of tests. All of those, it can actually, because the agents, right, they love reading documents, and they love answering questions without getting tired. So we can take advantage of all of these and actually go through every one of these, and then the adaptive execution, how do you daisy chain the vulnerabilities, and then, analysis, and then, assertion value. And then these are all the final outputs. It will provide you findings, proven, reproducible, and then next one is remediation, and then also step-by-step suggestions. And then we can take a look at it. We can see which ones are needed, which ones can be omitted, etc. So remediation, and then reduced, as we talked about, false positive alert, and then observability. So all the regulated industries, finance, health tech, whatever, they will need compliance, audit, provenance, all kinds of documentations. All of those as well, we can actually produce. Basically, it'll be part of the SDLC, part of your thing. And finally, what happens is whatever used to take weeks, we can actually reduce it to hours, and also in terms of cost as well. So that is the whole idea. We are actually throwing more context. We are trying to actually leverage in every step of the way. Okay. So now let's actually I'll show some screenshots first, and then later we can actually go to so maybe let me do this. Let me backpedal now. Let me quickly show some screenshots, and then I'll go to my environment. So this is actually preventing vulnerabilities early. So this is the design doc review at the early stage in the life cycle. Okay, earlier scale with proactive security. So you have, this is our, I'll show this later, security agent. And today it's available. If you're in AWS cloud, you can go, you can do security agent is there, and you can actually start deploying. You'll start with an agent space. That's what you'll first create. And underneath, it's like you can think of it as a compartment. Once you have it, you can actually bring in stuff that you want to test, secure test under an agent space. And from there, you can actually get, do the various combinations, and you can get the findings. So here, this is the security agent, and there is a design review, code review, and then pen testing. Okay. In the design, you will actually, there is a web app. That's where you can either, today we provide, I think right now we have like 10 checks that we do, and then you can bring in your own custom, I'll show you, custom your own rules as well. And you can enable, disable them, all of these. So in the design review, you can actually give in all your design docs based on the baseline, it will compare and give you, right? Now you can bring in your own custom secure requirements too, based on per project or whatever is not available off the shelf, etc. Based on your company needs, you can do that. That is also there, and you can. These are all AWS. Some is available, some is custom by a company or somebody, right? And you can enable them, disable them, toggle them back and forth. Okay, these are all available, and then this is like how do you define the custom requirements? There is this. You give a name and then applicability, compliance, and remediations, if any. If you think of a way you can specify, all of those is, and this is like a sample. Now let me, and then once you evaluate, it'll evaluate and it'll give you this thing. It'll say in terms of, how many is non-compliant, how many is insufficient data, compliant, and not applicable. This kind of a split, once it finishes the test, it'll give a report, okay? Then you can click on each of these, and then you can see whether the findings of the agent is useful to you or you can ignore it. Accordingly, those inputs that you give it back, feedback, is very important because it will help it to coach for the next run or something, okay? And these are kind of samples. This is like somebody wrote a custom, recommendation, custom rule. And it found, and it thinks it is non-compliant, and these are the reasons. And later you can say whether you accept it or you just want to tweak it or something. Okay. Now we finished all the design, code review, all of those stuff. No, not code. Now we are going to the next phase, which is in a PR. This is what I was saying. You connect it to your GitHub repositories. You can actually connect it. Once you set it up, when a PR is issued, raised, as the agent will be there, it is also doing a review of the PR. It is giving some findings here on this block of code. So it says, this is the issue, it thinks, what is the recommendation, blah, blah, blah. And then you can actually do a thumbs up or a thumbs down. You can say, this is a good finding. Then it actually takes it into useful things. Every time it will start using this as it'll start looking for this as well. Or you can say thumbs down, meaning it is a non-issue, please ignore it. Then also it'll take that as a feedback for the subsequent, for the posterity, right? So per PR, as it is happening near real time, meaning you'll see comments, it'll coming, right? And then this is the penetration testing, wherein you'll give your, the URL for your application. The only thing is, you as an admin, you need to own that. You need to be admin to that in the DNS name, because it needs access to actually go penetrate whichever step, every possible way. Okay, that's one thing. So there is an admin, and you'll have various users, developers. Sometimes if the developer is not having the elevated privilege or whatever, but through your IDP, identity provider, the admin or somebody has to create a group and add them and then give them the required whatever. But basically the point is that DNS name, if they have all the privileges to do the penetrative testing, that's one requirement. Okay, and you'll give it everything, and then it'll actually give you the results and findings. Multiple runs you can run. So previously we were doing it like every 3-6 weeks or something, right? Now you can actually do multiple runs, etc. And these are all how the charts will look like, the findings and all. So let me quickly, there's only 10 minutes, so let me quickly show my environment. These are all there are some more screenshots too, but let me actually jump onto this one. So this is my environment. Okay, give me 1 second. So this is my environment, security agent. So if you go here, you search for AWS Security Agent, you will get it, and then you'll create, the very first thing that you'll create is an agent space. And I created an agent space here. Once you create the agent space, web app, pen test, design review, code review, etc., everything is there, right? And then what I did is I went to the web app, this one, I created a penetration testing. This is penetration testing, this is design review. And then I gave a sample URL that we have, which is nothing but this OWASP application, the juice shop, right? And it did a run. It found this is all its findings. And accordingly, with highlighted, I can see which is low, which is high, medium. And these are all the findings. I can go delve deep, whichever level, and I can start assigning, fixing, or remediating, or assigning it to the right teams, etc. So that is one angle. The second angle is let's go to the design review. Here is the design review. Okay, and I gave a document which is nothing but this. The document is here. It is an sample application, right? So the company has a baseline security posture requirement standards established with the CISO, and this is a project that we are doing, an application, and we have this document. So we feed this in, and then it asks it to review, and it ran some kind of a run, and its findings 5, 3, 3, 2, whatever, and then I see all of these, and then if I click on this, okay, it's going to give the summary, etc. And then here I can go, and then I can give that whatever, thumbs up, thumbs down, etc. So all of those is there. So now we can say, it's not an issue, or is it useful, incorrect, etc. So all my feedback is useful for the agent to get coached. Okay, so I think that is all at a high level I had, and we can download the reports. And if you go look at this one, right, there are multiple runs that you can do, not like wait for some companies will have contractors who will come only for a few weeks, and they will do it, and after that you don't have a chance to do security run. You have to wait for the next time. But here what it is pen test. Once you configure, you get all of those things done, setups. This is the first run. I did it yesterday night, actually this early morning, 12:51. You can do multiple. I can do a start run now, and it'll do another run, and you can go through your application. It's pointing to an application's designed to do. Like you can think developers are checking in code, so CI/CD kicks in, it actually deploys it into production or somewhere, or in your your UAT or something. And there with that thing, if you have configured it right, it is actually doing a run. So you can take it to like a not like you don't have to be really CI/CD, but like you can have a cadence, and running it is nothing but a automation thingy. It shouldn't be a bottleneck. You should be able to run it and see the results and findings, and later you can see which one is useful and not. So with this, I'll take a pause, and then I'll field some questions. And it's kind of relatively fresh from the oven, so you can give it a spin, and more changes will be coming up. And like things we are interested in getting feedback as well, and we can take it up. Okay. That is all I had. And all those charts and all we saw, right? The, especially in this slide deck. So they're all there in this thing. The splits, how it is, and you can go delve deep and all of those stuff. So that's all I had. So here in this thing, there's one thing that I wanted to show you. The design reviews. Okay. In your custom, the web app, right? I want to go to the admin app, admin access. If I go to the web app, how to configure. So they've made it easy to configure. So if you go here, so you click on this, you get this bit. So you can, right now there's AWS managed, some rules are already available and you can bring in your own custom. You can enable, disable, toggle buttons. It's easy to navigate, all of those stuff. Okay. This is, your logs, and this is your, learning resources, multiple things that it's all available here. That's all I had. Any questions?
When you were actually doing this pen testing and you were running the agent on my code, is my code going to the LLM?
So basically you've deployed, not my code. So we have deployed an application. It is running in some environment, and it will be in the end it will be happening. Yeah, meaning we have spawned, as I'm an admin, I've configured to run pen test on your application which is running on some DNS name. So in the backend it will be exercising the LLMs as needed, but basically we are throwing in more context to look at everything possible to get a good list of findings. Yeah, as needed it will be using LLMs. Yeah.
But that means my code will be possible that my code piece will be going to LLM.
No, code pieces meaning, so one thing is, so when you are using a development tool today, right, forget about the deployed code, even development, right? I mean, let's say any of these tools that you use, the development, productivity tools, they are using LLMs, right, as you're developing. Like as you are, it is.
If I'm not using Kilo or Cursor kind of thing, just using plain VS Code, then definitely it is not exposed.
If you're not using any developer productivity tools from GenAI, then it is only you writing it. So I'm trying to understand the concern. What is the concern?
The concern is that because if your pen testing is running on my code, and some of these questions I have on my code, you are sending it to the LLM to get the answer, then my code is going to OpenAI or some other Anthropy, and I don't even know that your testing framework actually took my code and here in the
Okay, so that is a good point, but is the concern your code without any LLMs, you want to be the whatever that we have been doing before?
Yeah, because I'm talking in the point of I'm a security company.
Okay.
And I don't want my code to be any way like any LLM coming and looking at my code. So just to make my code more secure, more protected for my customers to use it and it's completely LLM.
Yeah, no, I get it. But for your application, right, for your company to develop, so basically what happens is, again, it's my a question that I have. I'm trying to get myself educated. With the pace of how everything is going, we have to also catch up, and for our upkeep, we will be using for your application some LLMs or no? It's completely.
Yeah, because if you are using LLM to test my endpoints.
No, I'm not. I'm not even coming the pen test. I'm saying for your application, as your task today, somebody comes today to you saying, security expert I need, and please penetrate, test my code or whatever it is. Give me all the findings, how to protect myself in this world or whatever, right? Because we don't know which third party we are bringing in, what tools they are using, all of those stuff, right? So for that, if GenAI has been in the mix everywhere, to catch the GenAI, we need to know what models are doing what, right? So in your code itself, you will be in some way, shape or form, you'll have to be aware, correct?
So basically, from the pen
Again, this is to educate me.
yeah, for pen testing, what I feel is that send the input and output for my endpoints so that whatever is getting out, test by that way with the data that if I am doing something bad, then definitely my API is going to do something bad. Test that way rather than sneaking into my code and whatever the code patterns and all these things. Instead of just the code testing, test with my endpoints and with the data to open up the problem.
Okay, so maybe let me ask you a different question. Let's take the the word LLM out of the mix, right? If in the traditionally what we were doing, right, in the static and the dynamic, if given to you everything, like, the GitHub with all the code and my SharePoint or whatever, Confluence with all my documentation, which led up to this application to be created. If I give you everything, let's take the LLM the old way, without LLM. If I give you everything as a pen testing company with full context, that will be valuable to you, right? Meaning, what it helps is the attack plan and the payloads and which areas their test harness might have covered, but what is not covered, you can add those gaps and test it out, right? So that is how we are trying to throw in the context aware, like more context, everything in the entire SDLC to make it, kind of a context aware agent. That is at least the motivation with all the tools and things that we have in the fast-paced world. Now the concept of LLM is more like, making it conversational, meaning we can be in natural language, it understands what programming language to convert. That's how I look at this. So I take the LLM as can my grandmom build a software application? So they will tell in English, whichever language, and they don't know SQL, they don't know anything. It'll create and understand, and it'll design patterns, it'll go to gang of 4 authors, build the observable pattern, whatever singleton, and that's how I consider LLMs. Your issue where it is valid is to build those foundational models. All the companies would have read through tons and tons to fine tune their model. This is my view. You can I will take that separate orthogonal. Basically, to come up with an FM, what did they do is a different story. Foundation.
It is coming at me, but not taking my data to train itself.
Yeah. So the question is, even for us, they say like, your foundational model, are you using anything that I'm sharing? Anything? Are you using to train your FM and a foundational model? Yes or no is the question. Then I will join you or not, right? I would take it for you, right? I mean, I'll tell you the one, I'm not saying drawback, but so when you only look at the input and the output and do the testing, which is all fine, but we won't know we have covered everything, right? Or
penetration testing, endpoint testing, you may cover everything.
If is possible?
With the synthetic data and try to push in some input and then change the input and see what is the expected output is coming on. And those input and output you can we can take it offline.
Okay, because there will be some areas which will be without context. Is my okay. So I need to remove this.